Welcome everybody to today's webinar. It is my great pleasure to host Dr. Christian Salas, professor at the Universidad Mayor in Chile. Christian will talk about modeling the growth of natural forests with scarce data. He will give a presentation that will be followed by a question and answer period, and we plan to wrap up the official part of the webinar by around 10 a.m. Vancouver time. However, Dr. Salas agreed to stick around for a little while longer to answer questions, and for networking, we found that helpful for previous webinars. And before I hand the floor over to Christian, I would first like to acknowledge that I'm hosting this webinar from my UBC office that is located on the traditional ancestral unceded territory of the Musqueam First Nation. The land UBC is situated on has always been a place of learning for the Musqueam, who for millennia have passed on their culture, history, and traditions from one generation to the next on this site. Second, I would like to remind you that the webinar is being recorded and will be posted on the IUFRO webpage in the next few days. And third, I would like to acknowledge that this webinar is part of the 2022 Forest Mensuration and Modelling Chats, which are organized by IUFRO Research Group 401, Forest Mensuration and Modeling. If you have any speaker suggestions, please email me. We started this year in February, and for this webinar, we had close to 300 registrations. I'm really excited about everybody who's able to join us, and if you have speaker suggestions, please email me for future webinars. As this is an IUFRO event, I would like to highlight IUFRO's mission to advance research excellence and knowledge sharing, and to foster development of science-based solutions to forest-related challenges for the benefit of forest and people worldwide. The webinar series is being organized in the spirit of knowledge sharing and to allow for some interaction and networking, while fewer in-person meetings are being organized due to COVID-19. And now that I've covered this official part, the IUFRO requirement, let's please help me welcome Christian Salas, and you can start sharing your screen and start with your presentation.
Is it working?
Yes.
Okay. Thank you for having me here, Bianca. And I would like to acknowledge as well all the preparation for this talk that we plan ahead for a long time. I would like to send my regards to all of the colleagues around the world. As far as I can see, there are a lot of people from different countries and continents. Therefore, I am quite happy for that. And I hope that I meet the bar for this talk. This is a joint work that we have been carried out for several years with some colleagues, especially with Paulo Donoso, a professor of silviculture in Chile, as well as Aaron Baisquitel from the University of Maine, and my colleague here in Chile, Joaquin Riquelme. Then basically, we are going to try to point out why natural forests are important, how modeling can become an asset for dealing with scarce data. We are later on focused on our study case that will be from Chile, our modeling strategy, as well as the assessment that we have for our current version of the model. Then, as we are very aware, forestry plantations are primarily based upon conifer species. We apply intensive silviculture for wood production. It's not new that there is an ongoing debate between forest forestry plantations and natural forests, especially nowadays due to climate change, carbon storage, and biodiversity related issues. Sometimes has been claimed that keep going with the current type of forestry plantations, single species and using clear cutting and so on and so forth, could be an alternative for coping with the climate change. Nonetheless, has been pointed out by several researchers that this is not forest restoration. Therefore, natural forests are key for several ecosystem services, as well as for understanding the complexity and diversity that they are able to harbor. And we need to understand them in a better way for decision making, as well as for mimicking what is going on in this sort of forest, and try to adapt those patterns in forest management. Therefore, I believe that they are the past, the present, and the future. That's all. Then, regarding growth modeling, I would like to try to have them have forestry plantations and natural forests regarding the advance of growth modeling. And according to my perception, as timber plantations are directly linked to the business, it's natural that we have been developing decision support systems based upon growth models. And that's very clear, especially in the forestry plantation sector all over the world, especially in fast-growing species. Nonetheless, for natural forests, overall, the aim has been basically towards scientific understanding, but not that much towards developing quantitative tools for decision making. Indeed, there are some exceptions, especially in the US and in some parts of Europe. But overall, I would say that most of our knowledge regarding growth modeling and native forests are probably based upon gap models, where the objective is a little bit different. Also, for forestry plantations, there are very good data, because the systems are much simpler. Therefore, we can develop and establish really nice experiments. We can test hypotheses, and several other stuff that we cannot control that much for natural forests. Physiologically based on or hybrid growth models approaches are easier to test as well in simple systems as forest plantations. But in most of the models that are applied in natural forests have been developed in ecosystems where there are few dominant tree species and with low biodiversity. They are largely developed for conifers, but not for broadleaf species, and heavily based for the North Hemisphere, but not for this part of the world. Then here is where I believe modeling becomes an asset, because in the ideal world, we build growth models based on data that are freely available from a network of permanent sample plots. And I am talking about, countries like the US, Germany, Austria, Canada. Then you have tree-level descriptions, regeneration, other features. You have stem analysis data, biomass data, and you have very good records of climatic stations. Therefore, you are able to assess different approaches based on the data that you have at hand, and depending upon the objective of your model. And finally, you just make a decision and develop your own model and use it. Nonetheless, in most of the world, of the rest of the world, we lack long-term data. Most of the time are not even available. The weather stations are poor, except if you are in a big city, but forests are not near big cities in most of Latin American countries. Therefore, it's quite different, especially the records for climatic variation that you would like to relate or try to connect with ecological processes such as mortality, for instance. These forests are also mixed species forests. There are a huge variability due to natural conditions as well as anthropogenic interventions. Because in this part of the world, most people depend on forests. Therefore, there are a huge impact. And they are high graded most of the time as well. Then we are faced with several challenges for building role models. Then, in the usual sense, we know that there are several processes that are underneath forest dynamics. From there arise some patterns that we are able to see through data that we have to collect. These processes, we try to frame them through mathematical models, and those processes as well are able to improve our mathematical models as well. And the data that we are able to collect are used for fitting new models and testing new hypotheses and so on so far. Therefore, I believe that there, in one side of the equation of this huge framework, we have mathematics. In the other hand, if you have data, you have statistics, where nowadays, through the use of several alternatives that are available, you can fit whatever model that you want to try. Nonetheless, modeling is set in the middle, I would say, in the sense that you or we have to face with the few data at hand, try to develop models that are able to mimic the processes that are arising in the patterns that we are able to see. Therefore, I think that when we don't have enough data from the very beginning, and we want to assign some uncertainty in our model, which I think is important because otherwise we can just build theoretical models and we don't care anymore. Modeling becomes an asset because we have to face this trade-off between these two worlds based on the data and the models and the knowledge that is all the time advancing. Therefore, we move to the Chilean case, our study site, let's say. Chile, as there are a lot of colleagues from several places in the world, is a very long and thin country in South America, from having very different climates, from desert to Antarctica, and the ocean from one side and the Andes for the other side. We are 70 million people, more or less. Most of the people live in Santiago, the capital of Chile. I'm not that sure if you are able to see this is a picture of Santiago nowadays, because just was snowing the last week. Then it's quite beautiful when it's raining. And other important cities are, Concepcion, where most of the forestry sector is located, Valparaíso, which is our major harbor, Punta Arenas in the Patagonia of Chile. And Chillán is not that important, but it's my home city, then it's important for me. We speak Spanish. Our economy is heavily based upon copper, and from there, the forestry sector is quite important, as well as salmon and wine. Is a model for free market for developing countries, and the gross domestic product per capita nowadays is indeed quite low comparing with Norway, with the USA, Canada, and Germany, but is doing very well if you compare it with our neighborhood countries like Argentina, Brazil, and everything is changing a lot. From a biogeographical perspective, Chile is usually considered as a geographical island because of the aspects that I was mentioned before. We have the second largest remaining area of temperate rainforest. This is a picture from NASA. Over here, you are able to see the Antarctica. Regarding the forestry sector, we have a very asymmetric, I would say, sections of the forestry sector. One is heavily dominated by the forestry plantations, about 3 million hectares of rhodeata pine, eucalyptus, globulus, and nitens. There are some Pseudoxura menziesi as well, and other species, but most of the forestry sector is based on rhodeata pine and eucalyptus, where we apply a highly intensive silviculture with thinning, pruning, and vegetation controls and everything. As you can see, the rotations are more or less 24 years old for rhodeata pine and 10 to 12 years for eucalyptus on average. We have more natural forests, almost 15 million hectares, aside of some iconic native conifers like Fitzroya cupressoides, which is a species that are able to grow up to 4,000 years old. Araucaria araucana, 1,000 years old. Most of our species are broadleaf trees and heavily dominated by the Nothofagus genus. According to Donoso, there are 12 forest types, and some of them have really high potential for forest management. Nonetheless, currently the forest management in native forests is less prevalent. Regarding the biometrics studies in Chile, I will focus on one of the forest types, the one dominated by Nothofagus obliqua, alpina, and dombei. And it's important to mention that the Nothofagus genus or Nothofagus species are able to find in not only in Chile but also in Argentina and in New Zealand. Then I will focus on the ones that are from Chile. Or these are I would say, the most productive native forests in Chile. There are really scattered works on biometrics or sort of studies on these sort of forests regarding volume estimation, site density relationships, some diameter increment models, and some productivity efforts as well as mortality. But some of them, or most of them, have several pitfalls, or because they are based on small sample sizes. Some of them are just carried out in a very specific location. Therefore, we need to build something that is more comprehensive. We don't have available permanent sample plot data. The Chilean Forest Research Institute, which is institution from our government, is supposed to carry the national inventory, where actually they do that, but the data is not in agreement with what you will expect for building a growth model, because the focus is more into providing estimates of forest stock. We have been trying to recover some old but well-established permanent sample plots in some thinning trials. And we start to establish new permanent sample plots in the last 20 years. Then, because of the structure of the forests, because they are mixed species forests, we aim at building a tree-level, distant, independent growth model, because allows for representing the species and stand dynamics. We have an impressive amount of ecological knowledge, I would say, regarding our forest, based on dendrochronology studies, and that's quite good, because we have some insights from or regarding the auto-ecological future of a species. Then that's something that we are able to test with the models that we are going to build. And that's important. I would say that this approach also is a good trade-off between the data that we need for building it and the data that we have at hand. Then this is like a starting point, but we later on can move towards something that is going to be more complex. And the other part that's important is, I know that in some countries, you can use LiDAR and drones and everything, but I would say that this sort of alternative could be more suitable for Chilean forest owners. Then we, as I mentioned before, we recover several permanent sample plots, in the sense that we visit them and we remeasure them, and we check all of the data at the tree level. And we started to do so even before that I moved to the US for my graduate studies. Currently, we have around 150 permanent sample plots. As something or a feature that I think that is important for growth modeling and monitoring, or especially if we want to collect our own data for growth modeling efforts, is the plot size. Then most of our plots are larger than 1,000 square meters, and because of some of the research that my colleague Paulo Onosto is carrying out in silviculture, we have some 1 hectare plots. We have been measuring all the live and standing dead trees larger than 5 centimeters. The period length for remeasurements is quite variable, between 3 and 12 years old, 12 years. But I would say that on average is about 5 years. We have been collecting regeneration, coarse woody debris. Just recently, we are collecting litter fall through time and improving our measurements on soil features, especially for deriving some water holding capacity measurements, and as well as leaf area index. Here is, you can see 4 different permanent sample plots. This is a Nothofagus lumbeyi secondary forest. This is a Nothofagus alpina. This is actually is a managed permanent sample plot from the oldest thinning trial in Chile. We have been putting a lot of effort on measuring the understory, because there are several species that are growing underneath the pioneering species that are mostly from of Nothofagus species, as well as we have some permanent sample plots in old growth forest. As you can see here, there are not many old growth forests left in Chile, but we have some of them are in hands of some universities and protected areas. Then we have that in the long term. Aside of the measurements that I was mentioning to you guys, we have been collecting and recovering stem analysis data as well from the entire distribution of this forest type for modeling. Model feeding purposes, as we have longitudinal and hierarchical data, we mostly use nonlinear functions, and we feed the models by maximum likelihood using mixed effects, and therefore we come out with multi-species and multi-level models depending upon the data that we have. Then we have the fixed effect part of this nonlinear model, and the random effects part, and the respective design metrics for it. One of the things that is really neat of feeding mixed effects models in this framework, and especially when you don't have that much data, is the future of calibrating the random effects, because through that we are in a context where people are not really measuring that much the forest. Therefore, if they are able to just measure a couple of, let's say, high diameter observations, we might be able to calibrate that through time. Therefore, we might correct the predictions, and at some point, this will become an adaptive growth model in the sense of correcting the predictions. We also try to make the most from time series, and therefore we use all of the combinations regarding the successive observations. That's a paper that we work with Aaron on, and we published it 2 years ago, something like that. Especially in some ecological processes like mortality, which is really complicated to model, but also it's very different depending on the period length or the exposure of the phenomenon. The simulator was built using Shiny. Therefore, we have the inputs. We have two models with static models and dynamic models, and later on a set of outputs. Therefore, within the static models, the high diameter allometry is quite important. We take a lot of care on trying to meet the auto-ecological future of the species. Here you have, sorry for the native names, but or the local names, Coihue, Raulillo roble are the Nothofagus species, the pioneer species. Laurel and Linge are shade tolerant species, and Oliviris is the most shade tolerant species. Then here you have total height and height to ground base. This is just, let's say, the fixed effects.
I found this on the web for how do turtles hibernate in days.
Sorry about that. For volume, we have been using several models that are available in the literature in Chile. There are not that much. Some of them are works that have been compiled by the Forest Service, as well as the Forest Research Institute, as well as some new analysis by other colleagues. Then we are testing and building new models for that as well by data synthesis too, where we want to, we are feeding a system of biomass component equations as well. For the relative density is an important part of our approach, because has been used a lot in forest management down here. Then it's an easy tool for using and calibrating or assessing if a forest is meet the requirements for applying some silvicultural treatments. Regarding the dynamic components, we built a model that depends on topographic features like elevation, aspect, and slope. We use some sort of the habitat type approach that we have here also, that is basically help us to represent some biographical areas. regarding climate, we use several features, among them the precipitation in the period of the year where is more important for tree growth, as well as the variability or the stationality of precipitation, as well as temperature. Regarding the diameter increment models, here we have some trends for the model, depending. This is a tree that is almost the most dominant tree. And if we move towards the to your right, this will a tree with a more suppressed tree, and you see the difference among the species as well, because we have several species growing simultaneously. Same thing for high increment. The mortality with model, as we are well aware, is basically the component that drives the trajectory of the model. And there have been a lot of work, especially in ecology, by researchers that are more interested at the global level of forest dynamics. And the results are saying that depending upon of the mortality model that you choose is the result that you are going to obtain. Then we took a different approach, in the sense that we use a Gonpit model, which allow us for representing the period length directly into the model and feed it as well as in a mixed effect framework. Therefore, the simulator flow is quite standard, I would say. You have to provide the tree list, and as well as the productivity, which you either give it as the number, or we have a map where you can just click on the location where your forest is, and the raster files are behind it. Therefore, we use that model for predicting the productivity based upon the climate features, the topography, as well as the habitat type. Due to that, we will have the features of the structure of the forest, the competition, obviously tree size, where we impute several other variables that are important, like crop ratio, for instance. Later on, we ask for the mortality livelihoods, and if the tree survive, we apply the growth rates that will update the state variables at the tree level, and will change everything. And otherwise will become necromass, and then we can compute that as well. We have been testing the model for so far 70 plots. And in the first column here, you see one plot, and the first row of the panel is tree density. The second one is stand basal area, quadratic mean diameter, and stand volume. You can see that these two plots, they have three measurements on time. In basal area and volume are doing very well. We can see that there are some difference in tree density. We need to test and assess that more carefully. But as far as I can see, the problem will probably due to small trees, because they're not important regarding basal area. And at some points there are important difference regarding tree density. Then this is, an ongoing work for the future as well. But so far, the errors that we have been computing are not as bad as we would expect. Then the first quartile is about 12% in basal area, and the same sort of thing for tree density. We feel confident so far regarding the model, in the sense that it's going to be able to at least depict the general patterns of what we know about our forest dynamics. Probably, I don't know if I have much time, Bianca, but these are, this is a stochastic model. Every time that you run the model, you are going to find different trajectories. Then here we have tree density in the deterministic case, and the stochastic simulations, as well as for quadratic mean diameter. The model is called Pellin. That's our simulator. And Pellin is an indigenous word that means very old Nothofagus obliqua tree. Then it can, although it's especially used for Nothofagus obliqua, can be related to any very old tree. And as all trees are very important features of forests, especially of native forests, we coined that name for it. And we also take into account the importance of native people as well on that. And the model is available in that website. We are hoping for improvement in the long run. And finally, I need to acknowledge several research grants, especially this is fun. This is like our NSF in Chile, is the Chilean version of the NSF in the US, and several other small projects and colleagues that they provide us with very important data for developing some of the models that we have been we have been using here, especially these colleagues. That's all.
Thank you, Christian, for the amazing talk and for all the nice pictures. It's so beautiful in Chile. I was there in 2001 for a 3-month internship. And if anybody ever gets the chance to visit Chile, do it. It's the forests there are beautiful. I'm going to kick off your screen sharing to quickly, where is my screen that I want to share? I think, that's not, here it is. This is what I want to share. So can you, share. Before I open up the question and answer period for Christian, I would like to remind you that we have NOS webinar in August, but then in September, on September 27th, we have another talk from Chile. This time, Dr. Trincado is going to talk about fast-growing, intensively managed forest plantations in Chile rather than natural forests. So that'll be really interesting to see us follow up to this talk. And the announcement, so the registration is not open yet. It'll be open up in a few days once I get the link sorted out. The announcement will be sent out over the Division 4 mailing list. You can register here, and Kate was going to, yes, thank you, Kate, put the links in the chat so you can copy those over. You will also find future announcements on the IUFRO calendar notice boards. And if you do have any suggestions for future speakers for the rest of the year or for 2023, please send me an email. And I'm looking forward to see you at the next webinar in September.